Okay, so I'm going to discuss to you this application of integration having area between curves. So this particular question will ask us to determine the area enclosed between the curves y is equal to x squared plus 1 and then y is equal to 7 minus x. We know that this is already a curve, but before that, how are you going to come up with this graph or this drawing? So we know that there is an intersection between two curves, that you have y is equal to x squared plus 1, and the other one is y is equal to 7 minus minus x. Okay, so from here we can equate this to equation. So you have x squared plus 1, and then the other equation, which is 7 minus x. These are values of y. First, this one is x squared plus 1, and that one is 7 minus x. So simplifying further, you have x squared, and then this one will becomes positive x, and then 7 will become negative 7. Okay, you have plus 1 minus 7 equals to 0. So you have x squared plus x minus 6 is equal to 0. By factoring this one, you can obviously have you have x and x. You have for 6 you have 3 and 2, and since you see here this is positive, that means this is positive 3. The bigger one is positive and this one is negative. So that means you have x plus 3 is equal to 0. So the first value of x is equal to negative 3, and then the second value of x is equal to positive 2. So you have two values. So you have here negative 3, and then okay, 2, positive 2. Now it's just easy for us to plot 7 minus x, because for y is equal to just like minus x plus 7. We know that 7 is the y-intercept, which is this one. This is 7, and then the slope is negative 1. Okay, so the slope negative 1, you see here, and just connect actually here this intersection negative 3 and 2. Okay, this will give you a slope of negative 1, which is 1 vertical and 1 horizontal. If you're going to plot this one, okay, this is actually 1 and 1. Okay, we can get this one as a value of this one could be 6. Okay, why? When x is equal to 1, what is y? Is equal to 6. It's from here. The drawing is not not being drawn to scale, but yeah, as you see here, the slope is 1, or 1 vertical, and another one is horizontal. Okay, so from here, let us compute now the area. If I'm going to, okay, let me introduce to you a differential strip. This is dx, and then this one, let us say this is y, and then you have here, of course, this height is, let us say this is y1, and then this is y2. What is y1 from this equation? Let's say this is 1, x squared plus 1. y2, y2 is coming from this curve. Okay, what is this curve? This curve is no. Okay, this curve is x squared plus 1, which is y2, and then y1 is this one, which is y is equal to 7 minus x. So y1 is 7 minus x. So as you see here, this differential strip, which is y dx, limits from negative 3 to positive 2. Y is equal to y1 minus y2. y1 is 7 minus x, and then minus y2. y2 is x squared plus 1. Okay, so the area is just y dx, limits from negative 3 going to positive 2. From here, going to here. Okay, this strip travels from this, going to here. Okay, you have negative 3, and then you have 2. 7 minus x squared plus, no, it's minus 1. Okay, this is dx, or should we say negative 3, 2, 6 minus x squared dx. From here we can integrate. This value becomes 6x minus x squared over 2 minus x cubed over 3. Negative 3 and then 2 dx. Ano? Plus, yeah. No more dx. Negative 3 to 2. So the area now, you have 6 times 2. Substitute the value of x, which is 2, minus 2 squared, 4 over 2, minus 8 cube over 3, minus 6 times negative 3 is negative 18, minus negative 3 squared is 9 over 2, and then you have negative 3 to the power of 3 is what? Negative 27. Okay, this will become positive, and then you have 3. So you can find here the value of a. Okay, using your calculator, you can have 6 times 2 is 12, minus 2, minus 8, 3, divide, equals minus 8, 10, 4.5, plus no, this is not this is already 8. Okay, not negative 8 to the power of 3. This is negative 2 to the power of 3. Okay, 6 times 2, 12, 4 times 2, then 2 times 2 to the power of 3 is 8. Okay, so you have 12 minus 2 equals minus 8, 8, 10, minus 4.5 plus 9. So you have 20.8. Okay, check your value of your area. That's correct. It's from my calculation, my calculator is 20.83 square units. Okay. Okay, second we have our second problem. You have this one. Now you have this area, so it's being bounded by the 3 straight lines. Y is equal to 4 minus x. Where is 4 minus x? So meaning the slope is for y is equal to just like minus x plus 4, negative 1. Okay, this one, negative 1 is vertical to 1 horizontal. So if this is 3, see, you have 1 vertical and then 1 horizontal. So you can do it also by having assumption when x is equal to 0, setting values. When x is equal to 0, y is equal to 4, and then when y is equal to 0, okay, this one is when x is equal to 0, y is equal to 4. When y is equal to 0, this is x is equal to 4. So you can plot this curve. Now similarly, y is equal to 3x. You can see here that 4 is the y-intercept, and it's coming from here. Y is equal to 3x, meaning it's a 0 intercept, so it's from here. One slope is 3 is to 1. 3 vertical, and then 1 horizontal. So you can draw it here. And for this one, y is equal to x over 3, or from 3y is equal to x. The slope is 1 over 3. 1 vertical, see, 1 vertical from here, 1 vertical, and then 3 horizontal. Okay, 1, 3. This is positive. This is positive. So our slope is going positively going to the right. Okay, so what are the areas? Introduce this loop coming from here. Introduce a differential strip, and then also here. Okay, so you have here area is equal to, first, from 0 to 1 y dx, and then the other one is from 1 to 4 to 3. Okay, 1 to 3 y dx. Let's say this is y1, y2. What's our y1? Our y1 is this line. You have this value of y is equal to 3x. So 3x minus this one, minus x over 3. And then you have y2. Our y2 is this one. Our y, which is coming from this line, which is 4 minus x. And then the y, which is coming from this mx over 3. Okay, so we can substitute. You have 0 to 1, 3x minus x over 3 dx, and then plus 1 to 3, 1 to 3, this is 4. Actually, this is, if we simplify, 4 2 times x, 3x minus x over 3. So this is 4 3x minus 4x. Okay, minus 4x over 3. Okay, so 3 over 3, yeah, minus 4x over 3 dx. So from here we can simplify the integral values. You have 3x is 3x squared over 2 minus x squared over 3 times 2 is 6. This is 0 to 1. And then you have here 4x minus 4x squared over 3 times 2 is 6. Okay, this is from 1 to 3. So we can simplify. This gives us 3x. No, the value of x is already 1. Okay, 1 squared over 2, or 1 squared. You can just have 1 over 6, and then minus 0. Everything is 0. And then you have here 4x. 4 times x, 4 times 3 is 12, minus, this is actually 2/3, 9, and then minus 4 minus 2/3. Okay, so from here you can compute the value of area. Okay, area would be equal to, you can just use your calculator. This is 0.5. This first is 1.33. The other one is, this is 3 and 9 is 3. 3 times 2 is 6. 12 minus 6 is 6. And then you have, no, this is minus 4 minus 2/3 It just actually 4 times 3, 4 times 3, 12, minus 2 is 10 over 3. Okay, you can get the area. 4 minus 1.33 plus 6, or 4 square units. Okay, so that's all for the application of integration bounded bounded between curves, or area between curves. Thank you.